Good afternoon, everyone.
Good afternoon, ma'am.
Okay. As usual, questions. Do you guys have any questions? Okay. Any questions from the homework before we start the new material? Get going. And please put your camera on. Please put your camera on. Thank you.
My grandfather's still in the hospital. I haven't been able to go to his house and get my webcam back yet.
Okay. Anybody else?
My camera is also having technical difficulties. I'll try to work on it over the weekend. I haven't gotten it
Thanks.
yet.
Yeah, please do. It's helpful for me to see your faces. All right. So, all right. So we go through your questions and we proceed. Wait. So 1.9, 14, 17, 18. Okay. So let's look at 1.9. That's what seems to be giving to trouble. So we look into it. Okay. Number 14. So I read it. Okay. And we have to interact with it very well. So number 14. At 1.7, I did them last time. So I cannot redo the problem. So today I do only 1.8, 1.9, or we will never be done. Okay, so 1.7, it was done last time. So I will not answer them today, but I will definitely answer 1.9 because that's today's homework. So 14, I read it and we have to understand it. Let's suppose that a function f, so suppose f, sorry, is the function that to each positive number s, it assigns the perimeter of a square, each of whose sides has length s. Is f increasing, decreasing, neither, whatever, explain. All right. So this is the problem. Step number one, we have to understand what are they talking about? What is this function they are talking about? And then once we do that, we answer the question. So again, I start asking you the following. So you have this function. It means you have this machine. That's number 14. You're going to give it an input and it's going to give you something. So back to you now. What is the input? What do you give f? What's f doing? And what f should give you back? So to each positive number assigns the perimeter of a square. All right. Who would like to talk? What is this function doing? What do you give it? And what does it, this function assigns to what you give it?
So you give it a positive number.
Yes.
And it will give you the perimeter of a square who has the sides of that length.
Right. Side s. So you give it a number and it's going to give you the perimeter of a square of side s. That's what this function is doing. So let us, before even we fully understand this function. So you give it s, a number s, and f of s gives you the perimeter of the square. So f of s here in word gives you, the perimeter of the square of size s. Perimeter of square of side s. All right? So if s is 0, what if f of s?
0.
0. It means if you have a square where the side is 0, then the perimeter is 0. If s is 1, very quickly, what is f of s?
1.
What? Please hurry up. I'm listening.
1.
So that's the square. If the
It'll be 4.
side, right, if the side is 1,
Oh,
the
shit.
perimeter is going to be 1 plus 1 plus 1 plus 1. That's the function. I keep going. If the side is 2,
8.
8. Picture is clear. The side
Okay.
3,
100.
what? If the side is 3, from here to 3, the perimeter is 3 plus 3 plus 3 plus 3.
12.
12, exactly. If S is 4, what's the perimeter?
16.
16. It's 4 times 4. So just out of curiosity, not curiosity, I can go on forever doing this. Or I say, instead of giving Q for every side, okay, I tell you, if I let S be the symbol for the side, what is the general formula for f of s?
S times 4.
Fourth S, exactly. That's what we talk about the formula. So instead of telling Q, I say f of x equals something. Instead of telling Q what x does to every input, the input's changing a lot. We just give it to you in general. So that's really the function f. Now, is this function increasing or decreasing?
Increasing.
Absolutely increasing. Intuitively, when the sides gets bigger, the perimeter is going to get larger. So here, if I sit down and graph the function, suppose I graph the function, S is the side. On the vertical axis, I'm going to put the perimeter. And then I draw a point. S is 0, 0. S is 1, it's 4. S is 2, 8. And I start connecting. I'm going to get, this is the graph of my function. Okay, so the function is increasing because as the side increase, that's the input, the perimeter of the square will increase as well. Or the graph is the graph of an increasing function. All right? Questions, please?
How do you want us to write that down on for when we answer it on the quiz?
F is increasing because if you graph it, because the graph rises as you move from left to right, or you can say because, which is actually what's happening, as the side of the square gets, the side is the input, as the side of the square gets larger, what will get larger? The perimeter gets larger. That's the way actually I see it, this way. As you increase the side of the square, the perimeter, which is the output, is also going to get larger. It means increases in value. So either you sketch the graph and you tell me graphically the graph is rising as you move from left to right, or in word, as the side increase 1, 2, 3, the perimeter itself is also increasing. All right, so now I look at 17, 18. Since they are fairly similar, okay, let's do 17, 18. Okay. So we will not do all 4. I will pick this and that. So I'll pick 2 of them and we do them. So I will not do all of them. In this problem, we assume the graph keep going forever, like this. All right, so the graph is not stopping, it keeps going. And the question is, on which interval is the function increasing? Okay. So we're going to write it like we did last time. On which interval, so I'm doing the first one, on which interval the function is decreasing? Okay. All right, quickly, who would like to tell us?
A negative infinity to -3.
Negative infinity to -3. So let me exactly on the book here. Up to here, the function is decreasing. Keep going.
And 3 to infinity.
3 to infinity. This is the 3 up here, so it's not crystal clear. So we'll accept 3. Almost if you say 4, I will accept it. Up to here, it is decreasing. Or you can say, as I did last time, for all values of x that has the property x less or equal to -3, or x larger or equal to 3. Okay, so you can either give me an interval notation, or you will have your choice. You can write it in words, whichever you're more comfortable with. Okay.
On the answer sheet, they kind of write it differently. So do you want us to write it the way that you're writing it?
Yes, it's all the same. I mean, basic. I didn't look at the answer sheet. I'm sorry, I should have.
The answer sheet was saying for decrease, it was in a bracket, and they put -3, 4.
Okay. They closed the bracket here.
Yeah, but they didn't have infinity. They just had -3 to negative.
No way. They have to.
4.
They either write it x less or equal to -3, or they have to write it this way.
Okay, so
yeah,
the worksheet is wrong.
No, it's not wrong. I have to look it up. So that's the interval notation. It has to go. It has to start somewhere, and it's telling you everything less than -3. And now, yes, they put 4, which is, I think it's 4. Your classmates saw it up to 3, and I said I will accept that. Okay, but I think if you look at the graph very, very closely, because it's not crystal clear, I think it's from 4. So this way. So it's just a matter of looking at the graph. But I accepted it from your classmate because it's not really too much off. Okay, so either this notation, which is the interval, or you write it in words. But there is this notation doesn't make any sense, but by itself. You have to have something from where till -3. This is telling you everything before -3.
Okay, so don't write it like how it is in the book.
Did you understand this way of writing?
Yes, but I'm trying to understand if writing it the way in the book is wrong.
Don't worry about it. Don't worry about it. Just if you understand this, use this notation, okay? And I will look at the back of the book to make sure that there is no confusion. Okay. Now, f is increasing. Anybody would like to answer this?
Can you please repeat the question? Sorry.
Increasing.
From -3 to +4.
Right. So how do you want me to write it? If I use interval notation, what do you want me to write?
It would be from -3
4, close the bracket. Okay? In words. All axes such that what? Okay. How can I describe in word the axis in this interval? It means where should be the x?
Greater than or less than.
Greater than -3, that's this piece, and less than 4, which is this piece of the inequality. So it's like a double inequality to express two things.
Okay.
All right. Okay, now finally, I look at number 18.
Could you go back to that one for 1 second?
Absolutely so.
Thank you.
Sure. Number 18. Again, it's the same type of questions. So number 18. Okay. And the question is interval where f is, let us say, decreasing. would like to tell me quickly when is f decreasing? When the graph is actually falling.
3 to infinity.
3. So let us agree on that, all of us. This time 3 is the correct number. So either on the interval 3 plus infinity, interval notation, or in words, all values of x, that has the property that x is larger or equal to 3. All right. Now, when is f constant? It means the output doesn't change value.
Would it be -2 to 3?
Right. The output is 7, 4, 5, 6. Sorry, the output is 6. The output does not change at all. If I take any input between -2 and 3, any input, the output is 6. Sorry, 5, 5, 5, 5, 5, 5. That's what the constant is. So f is constant for x on the interval -2 all the way to 3. Or you can say for all input values, which are, the input has to have the property that the input should be less than 3 and the input should be bigger than -2. Okay?
All right.
Any questions about those ideas? Okay. So as I said, I answered the question which are pertinent to what I've asked before. Like 1.7, I will not go back to it because we've talked about it last time. Otherwise, we will stay in the same section the whole semester. Okay, any other question from the new material? Okay. So today we're gonna move to section 1.10, which is, I don't think, I hope it's not hard. Rate of change. So section 1.10, rate of change. Rate of change is usually the idea of how fast things changes. It's the heart of calculus, basically. So it's the rate, how fast things change. So first I give the definition of it, and then we work examples to help us understand the concept. So first, just a definition. So suppose you have a function f of x. So when I say f of x is a function, it means I am thinking in my head about a rule that, it's always there is this rule, you give it an input, which is changing, and for every input, it's gonna give you an output. So let f of x be a function. Then the average rate of change that a lot of time we will abbreviate it to average rate of change. So that's usually the abbreviation of it. So the average rate of change of f, of the function f, for x between a and b is defined by, so that's the definition, and then the explanation. Okay, it's defined by f of b, the output at b minus the output at a, divided by b minus a. Okay, so we're going to take a graphical example to understand graphically what does each piece of the average represent. Okay, so I'm going to sketch the graph of a function. Okay. Can I move this paper away a little bit?
Yes.
Okay, so I'm going to graph a function. So let's see example. Okay. I'm going to take the following graph. So I'm going to graph here So the x value is here, and the output values are on the y-axis. So my function is simple. I'm going to draw it with you. So in case you're taking note, you can do that. So at 1, so that's 2, and that's 3. No, that's 4, that's 6, and that's 8. And this is my function. This is right here. And it's curving. It curves like that. So that's my function on the interval 1, 3. And we are going to compute the average rate on the interval 1, 3. The definition tells me to be able to do that, you have to compute f of b minus f of a over b minus a. So before I do this, let us get one thing straight. What is f of 3 in my picture? Quickly.
8.
What?
8.
No, in my graph, what is f of 3? It is 3.
8.
What?
8.
8. Very good. No, I know. What is f of 1 in my problem? My problem. This is 1.
2.
2. This is 1. You go up 2 when you hit the graph. Now, the average rate, the rate of f for x between 1 and 3, the formula tells me it's equal to f of 3 minus f of 1 over 3 minus 1. That's what the formula tells me. But now I want to understand what does f of 3 minus f of 1 is. So I'm going to back to my picture. I want you to listen to me. F of 1 is the value of the function at 1. So it's this 2. F of 3 is the value of the function at 8. So when I'm going to take the value of the function at 3, take away the value of the function. So this is f of 1, and this is f of 3. So when x changed from 1 to 2, the output was at 2, right there. And then the output at 3 is at 8. So f of 3 minus f of 1 is actually tells me how much my output changed between 1 and 3. So this is f of 3 and this is f of 1. So when I compute f of 3 minus f of 1, what I'm doing is the following. From 1 to 3, my output was 1, was 2, then it's 8. So f of 3 minus f of 1 is going to tell me how much my output changes. So this is from here to here. This is the f of 3 minus the f of 1. This distance from here to here. We were at 2, now we're at 8. So we changed by that much. And this f of 3 minus f of 1, we give it a letter and we call it delta y. Okay, so step number 1, we're going to understand what does f of 3 minus f of 1 represent. So f of 3 minus f of 1 is actually the change, it is the change in the y value, how much the y value changed. It was at 2 for 1, then it moves all the way to 8. So when I take the difference, it means by how much change? It changed by 6 units from here to here. So it's the change in y value when x is between 1 and 3. So that's going to be the top part of f3 minus 1. It's how much the y value changed. And we use the notation delta y. Now, where is the notation delta y coming from? Delta, that's called delta, is basically the Greek letter for D. So that's the Greek letter for D. For D. And where is this D coming from? This D is coming from the difference. So that's why we use delta y. It's the difference between two quantities, f of 3 minus f of 1. So on my picture here, the numerator is actually how much my output changed. Now, what is the 3 minus 1 in my picture? What 3 minus 1? I go back here. For x between 1 and 3, the 3 minus 1 is actually how much your x changed. So imagine yourself, you're moving along this line. You are at 1 and you go up to 3. So basically, if you move, by how much did you move? By how much your x value changed. So this is 3 minus 1. So the distance from here to here, this horizontal distance, this is the 3 minus 1. And this is what we call delta x. So the denominator in the average rate is actually how much your x changes. And the numerator here is how much your y changed. So 3 minus 1, the denominator, is the change in the x value when x is between, or if you want, when x increases from 1 to 3. Okay? And we denote this by delta x. So I go back to my picture. So when x goes from 1 to 3, so the input increases, my output was at 2, then it's at 8. So f of 3 minus f of 1 is telling me how much my output changes. And the 3 minus 1 is telling me how much my input changes when I go from 1 to 3. What is the average rate? The average rate of change for x between 1 and 3, it's equal to, I'm going to skip this one. Definition tells me it's f of 3 minus f of 1 over 3 minus 1. So we can rewrite it as how much your y value change over how much your x value change. So now in numbers, f of 3 is 8. F of 1 is 2. This is how much your y value changed. 3 minus 1 is 2. That's how much your x value changed, which is equal to 3. So that's my average rate in this picture. So we go back here. It makes it a little bit complicated at the beginning, but so what's the average rate from 1?
Excuse me.
Yes.
I think you're going a little bit too fast. Can you go back to the bottom real quick so I can catch
Sure.
up with the notes? Thank you.
And I will give 1 minute for everybody to take a breath. Thanks for letting me know.
So 3 would be the average rate of change, right?
3 will be, yes. It's
Okay.
how much your y changed. So we were at 2, we went all the way up to 8. So we changed the y by 6, divided by how much your input changed. It changed by 2. And that's the ratio between both changes.
Okay. And will it always divide at the end, like perfectly?
No, absolutely not.
Okay.
Absolutely not. There is no reason it will divide at the end. Absolutely not. Okay. Did I give you time? Do you guys finish?
I'm okay.
Yes. Please let me know when I'm going fast. It's your responsibility. I mean, I'll put it on you. So let us a little bit sum up. What is graphically what we're doing when we compute the average rate between 1 and 3? We ask ourselves, okay, the output it changes. It was here and my output is there. So the average rate, we take how much the output changed. If we go from here to here, my function has this value and my function. How much is changed, but I divide it by the change in input. So that's really the average rate of change is the delta y over the delta x. change of output over change of input. Okay. Questions? Very good. All right, so if I go back to the original definition, which is what it is, I can add here, since I explained what the delta is, so I can write this is the delta change in the y value over the change in the x value. Okay, and the y value, so in the picture is, so in the picture here, suppose I call this A if you want, and this B. It means this is like the 1 and 3 that I had before. So when x goes from A to B, this is my f of A. And this is the f of B. Those are the output. From here to here, this is the change in Y. And this is the change in X. Okay. So now we're going to take examples. The first two examples are word problem, very simple word problem to actually help us understand what does the average rate of change. And when I hit that, you will start realizing that it's not really a weird concept. It's a very, very logical concept. So my first two examples are word problems to help us understand the concept. And then we will do some symbolic problems, which are crucial for us as well. So this is my first simple scenario. I have a function f of t, and my function is the following. It gives me the population. It means my output is the population. So it's the population in a certain town, whatever you make up the name of the town, at time t, where t equal to 0 correspond, let us say, to the year 2000. I just picked a year. So here I'm talking about a function. You input the time after 2000, it will output the population in this town. And I'm going to give you the graph of this function. So I need a pencil because here I do mistakes. So this is the graph. So I say time here, I'm looking at it as the input, which is in years. And my output is the population. Now let us say these are some numbers. So initially at t equal to 0, which means the 2000, we had 10,000 people, all right? And let us say after 5 years, the population grew. So it's 10,500. I'm taking simple numbers in this problem. And then let us say I don't want to take the same interval. After 8, the population grew and it is 10,860. So now my graph is going to look like that. Bunch of dots, and I'm going to connect them. So this is the graph of the population. Okay. So let us make sure here we understand verbatim. So that's the time, and that's the function, which gives me the population. T equal to 0, we have 10,000. T equal to 5, which corresponds to 2005, it's 10,500. And 8 is 10,860. These are the number I give you. Okay, that's the picture, and that's okay. My goal behind this problem is to ask the following question. When was the population changing fastest? Between t equals 0, t equals 5, or between t equals 5, t equals 8? So the population is increasing. When was it increasing fastest?
T equals 0 to
minutes.
T equal 5.
Because
From 0 to 5, it boosted up 500, and from 5 to 8, it only went up 360.
Cap.
be careful. It grew up by 500 over how
Those
long?
5 years, yeah.
5 years.
Yeah,
But it grew up by 360 over how long?
3 years.
3 years. That's where the average rate of change start becoming extremely useful. And let us see in what sense the average rate of change is the way to answer the questions we are talking about. Are you with me? That's really why where is it growing faster? That's not the same time interval. Okay, and that's really one idea how we can figure out when is it growing fastest. So now my question is going to be the following. Question number 1 is find the average rate of change of the population for t between 0 and 5. Okay, what's the average rate of change? All right, it's equal to the population at 5 minus population at 0 over 5 minus 0. So I write it to remind you that's really the definition. There is noise in the background. Let's see if I can kill it. All right. So, which is basically the top, I think of it as delta P. Why did I write delta P? I didn't write delta Y here. I wrote delta P because it's change in population. So it will be silly for me to write Y because it's the population. And this is the delta T. That's the change in time because that's my input. So it's equal to what? After 5 years, the population was 10,500. Initially, it was 10,000 divided by 5. So it means that the population changed 500%, but the change occurred over 5 years period. Okay, so when I divide, I'm getting 100. But what does the 100 represent in this context? Let us understand the 100. So the population, let me go back here. Between 0 and 5, the population, that's 5. The population changed by 500. Okay. So it took 5 years to change by 500. So when I'm dividing 500 by 5, getting 100, who can explain to me what's this 100? That's the average rate.
It's 100 a year.
Exactly. It's 100% per year. The per year is crucial here. It means on average, that's, we're gonna call this the unit of the average rate of change. It's person per year. It means on average. So if I ask you to interpret your answer, what am I expecting you to tell me? To tell me on average, the population increased by 100 per year. When T is between, so that's for a very specific, T is between 0 and 5 years. Okay, this means on average, that's how fast the population was changing. Now, in the graph, let us show the numerator in the graph, and let us show the denominator graphically. So we understand the picture related to the one before. When time goes between 0 and 5, the population was 10,000. The population increased to 10,500. So this here, from here to here, that's the change in population. From 10,000 to 10,500, the population grew by 500. That's the 500, how we visualize it on the picture, by how much the population grew. From here to here, this piece here, that's by how much the time it changed. Between going from 2000, because u equals 0 is the year 2000, the time, it means over 5 years period, the population changed by 500. And the average rate is the 500 divided by 5. So this tells me that on average, the population increased by 100 per year. It doesn't mean exactly 100 every year, but this is like your average velocity. When you tell me your velocity is 60 miles per hour, does not mean you're driving 60 miles per hour all the time. You can drive 40 because the police is around, then you're gonna go all the way hit 100 when the police is not around. But you can average is 60. All right, B. Let us find the average rate of change of the population between the years 2005, which is t equal to 3, and 2008, which is t equal to 8. Is on average, how fast was the population changing between those two times? I back up to my picture. Who can give me the number, and then I will work it out with you. So now, from 5 to 8, my population changed. What's the average rate of change? For those who figured it out, write it on the chat, and then I work it out for you guys. $120. What's the unit, Matt? 120 what?
120 people a year.
Right, 120 people per year. So let us see again. Between 5 and 8, the population, so during this time interval, at 5, we were at 10,000, but the population grew to 10,000. So in this time interval, the change in population was 10,860 minus 10,500. It means the population grew by 360. How long it took to grow? That's the change in time. So that's the change in time in this case. It's equal to 3 in this particular scenario. So what's the average rate of change? The average rate of change is as we did, the population at 8 minus the population after 5 years divided by 8 minus 5. So it means 360. That's by how much the population changed over the time it took.
Add him to the meeting collection. I do want, these people in HFC. This is the first step.
Sorry, which is going to be equal to 120. So it means people per year. Okay. So now I ask my original question again. When was the population increasing fastest? From 0 to 5 or between 5 and 8? When was it increasing fastest? What?
Between 5 and 8.
Absolutely. Now we can answer the question without any hesitation, because between 5 and 8, it was increasing, it was averaging 120 people per year. However, here it was averaging 100 persons per year. So when was it growing fastest? The best way to answer this question, if you're comparing the growth of a population between two time periods, the best way to do that is computing the average rate of change. I mean, per year, how fast the population was changing. So now if I want to make the comparison, that's a definitely better comparison. Now I know which one, where it's growing fastest. Okay.
Can you go back up to the graph real quick? Thank you.
Okay. Everybody? Everybody is done. Please be honest and tell me. Okay. So I'm going to do one more problem. So because we're going to have a quiz, I will not do what stuff I had in mind more to do. So example number 2 along the same line. So I'm still doing word problem just because I want you to understand the concepts before we do the symbolic stuff. I'm going to create another scenario. My function now is the temperature. So throughout a day, the temperature changes. We know that. So it changes with time. In the morning, we have a temperature, and then the temperatures varying with time. And suppose f of t represent the temperature in degree Fahrenheit in Chicago on specific day. Let me pick January 1st, 2021. Okay. And temperature is in Fahrenheit, is in degree Fahrenheit, and the time in hours. So these are the unit I'm going to use. Okay. And this time I will not draw a graph. I'm just going to give you a bunch of values that make sense. Okay. That's the time in hours. And that's f of t in Fahrenheit, degree Fahrenheit. Okay. And let us say, for example, 0, which represent, for me, 0 here is 12 a.m. in the morning. Let us say the temperature was -3. At 6 o'clock in the morning, it was, I'm just making up those numbers. I'm trying to make up good numbers, 13. And at 6 in the evening, it means 18 p.m. It's, suppose it's 7. And finally, at 24 is -3. So what's the temperature? So it's increasing. So the temperature increase basically up to 12 noon. And then after 12 noon, the value of the temperature are starting to go down. So really the temperature is decreasing. Okay, that's really the picture here. And my question is simple. Find the average rate of change of the temperature. It means of the function f, because f is the temperature. Find the average rate of change of f for t between, let us say, between 12 in the afternoon and 6 p.m. On average, how was the temperature changing? And then give unit with your answer. Okay. All right, so what's the average rate? Okay, it's the temperature at 18. That's the formula. So always the output at the right end point of the interval minus the output at the left. So we always move from left to right. Divided by, if this is 18, below it, it has to be 18 minus 12. Okay, so that's the formula. And in notation, I'm going to write that's the change in time between 12 and 18. And what do you want me to use for the delta here? Delta what? Which letter is a good letter? What's a good letter?
Fahrenheit.
What?
F for Fahrenheit.
I didn't hear you. I don't know if anybody did.
F.
Can you write it down? Somehow I can't hear you.
F for Fahrenheit.
Okay, you can put delta f of t. Okay, absolutely correct. Another letter you can create your own is capital T. Why does this also make sense? It reflects what? Why do you think this capital T is a good notation? What does it reflect, the T?